first one? X to the what? 1/4. How'd you get that?
You multiply the exponent.
Good. You multiply the two exponents. Raise the power to a power and you multiply. How many of you got 100% correct? Raise your hand. Okay, good. With this next one, let's see. You did what? What's the mathematical term for what you did? Distribute. 8p times negative 3p squared is negative 24p cubed. Very good. 8p times 6p's is good. Positive 48p squared. And then we have 8p times negative 2, negative 16p's. Can I add those up? So people do that on the final. It was not good. We can't add those up. That is all that we can combine. These are not like terms. So this is our final answer. How many of you got it 100%? Awesome. Yeah, good. Okay, good. All right, so today we're getting into our unit of quadratics, a huge, huge deal in secondary math 2. One of the biggest things you'll learn in my class. And I know I said that a lot about quite a few topics, but really, secondary math 2 is the most important foundational math class. So you're just learning a lot in this class. So we're getting into our quadratics. We're doing quadratic graphs and their properties today. So, recall a polynomial of degree 2, such as negative 16x squared plus 64 is called a quadratic polynomial. Looking at this example, how do we know it's quadratic? What'd you say? Sorry? Very good. The highest exponent is degree 2. Is 2, so it's quadratic, right? We know how to name a polynomial. We know this is quadratic. Does everybody see how it's quadratic? What makes it quadratic? Okay? So a quadratic polynomial, such as negative 16x squared plus 64, can also be defined as a quadratic function. So, in other words, a quadratic polynomial is a quadratic function. So in this unit, we're going to be dealing with degree 2. We're going to be dealing with quadratics as our highest degree. Okay, so some essential understandings about quadratics. We're kind of learning just all the basics about quadratics today. So a quadratic function is a type of nonlinear function. Now remember, a linear function is a straight line. The rate of change is increasing or decreasing at the exact same rate. That's with a line, right? Rise over run, rise over run, rise over run. It's the same every time. But quadratics, this is not true. The rate of change is not constant. Also, the graph of a quadratic function is a symmetric curve. Does everybody see this symmetric curve? This is what a quadratic looks like. The quadratic curves will have a highest or lowest point that corresponds to a maximum or minimum value. So look at this curve here. Does everybody see how this right down here is the lowest point? This would be considered a minimum value because it's the minimum value on our quadratic function here. So you're going to hear quadratics called quadratics, obviously, or parabolas. So parabola, quadratic, same thing, just different ways of saying it. You're going to hear it both ways all the time. Let's all say parabola so we can practice. 1, 2, 3. Parabola. 1, 2, 3. Parabola. So a parabola is a quadratic. So you just have to know that. Okay, so some key concepts to understand. You'll want to write this down in your notes. A quadratic function is a function that can be written in this form. Y equals ax squared plus bx plus c. So we have ax squared plus bx plus c. So this is the standard form of a quadratic. That's the most important thing to get out of this. This is considered standard form of a quadratic function. Ax squared plus bx plus c. So notice a is in front of x squared, b is in front of x, and then we have our c, our constant c. Now the reason I just have this little a cannot equal 0 is because that would make our function not quadratic. Because let's think about it. This a is being multiplied to x squared. If it was 0, we would have 0 times x squared, which would be 0. So we would only have bx plus c. Well, now it's become linear. So our a values will never be 0. Does that make sense? Okay. So once again, this is the standard form of a quadratic. So here are some examples of some quadratics in standard form. We have y is equal to 3x squared. Now notice, it's in standard form, but I only have ax squared. I'm missing bx and c. Does everybody see that? Still in standard form. We have another example. Y is equal to x squared plus 9. Also still in standard form, it's just missing the middle term, bx. We have our x squared plus 9, the constant, but we're missing our bx. But it's still in standard form. Here's another example. Y equals x squared minus x minus 2. This is in standard form. We have each piece. Ax squared plus bx plus c. Are we all good with that? Just what a quadratic looks like in general. We're just getting familiar with quadratics, okay? First thing to know, a quadratic has the simplest form. So the simplest form of a function is always called a parent function. So really, if you think about it, we all come from our parents, right? So parent functions is where it begins. So a parent function is the most basic, non-shifted, non-stretched, or compressed function. This is the parent function for a quadratic. So every quadratic we see is going to be a form of y equals x squared. So y equals x squared is the parent function of a quadratic. Or we could say f of x is equal to x squared. Technically, f of x is nicer because that just means we have a function of x. Remember, f of x and y are the same thing. So either or. So this is the parent function. Couple things to note about the parent function here. This is the most basic non-shifted quadratic function. Notice, everybody, do you see how this point right here is at 0, 0? Yeah? This is our lowest point, right? On the parent function, our vertex is going to be at, oh, you don't know the word vertex yet. We're about to get there. Your minimum value is at 0, 0. Does that make sense? Is everybody good with that? 0, 0? Okay. So we already talked about how the graph of a quadratic is a nice, pretty U shape, and it's called a parabola. Okay, so once again, you can fold a parabola so that the two sides match exactly. This property is called symmetry. So look right here. If I drew a dotted line on the y-axis here, do you see how if I took it and folded it, boom, like a stamp, it would match exactly? Does everybody see that? It's symmetric on the y-axis. Do you all see it? Yes or no? If I took it and folded it. This is called symmetry. So the folder line that divides the parabola into two matching pieces is called the axis of symmetry. So this dotted line right here on the y-axis is our axis of symmetry because it's symmetric on each side of that line. Now also, this is on the y-axis, but also it's at the x value what? What x value? Because our y values are changing on that line, but what is the x value? 0. So this is the equation for our axis of symmetry. X is equal to 0. And also our axis of symmetry is on the y-axis. X is equal to 0 on the y-axis. Okay, so now you guys know that a parabola can have a lowest point or highest point. By definition, this is called a vertex. So you're just going to have to know that. I'm going to say find the vertex. You have to be able to say, I know that means to find the highest point or lowest point on my parabola. So once again, the highest point or lowest point of a parabola is by definition called a vertex, which is on the axis of symmetry. So look at this smiley face parabola here. Do you see this lowest point here? My axis of symmetry is going to run through that point. So everybody look at my frowny face. My axis of symmetry is going to run through that maximum value. So this has a minimum, right? That's the lowest point. Is everybody seeing the difference? Lowest point's a minimum, right? Highest point is a maximum. And our axis of symmetry is going to fall on that. So here's the deal, guys. This is what the big aha moment of this piece of my lesson needs to be. Does everybody see the difference between something facing up and down? Upward facing parabola, downward facing parabola. What makes it face upward is if that a value in front of x squared, so in front of x squared our a value, so we only look at the a value in front of x squared. If that is positive, it's going to be an upward facing parabola. Now, an easy way to remember it is positive people smile, right? Positive people like to smile, so that's going to be a smiley face. So it's an upward facing parabola if that a value is positive. We only look at the a value. It doesn't matter what's after that. If that a value is positive, it's going to be an upward facing parabola. So once again, if the a value is negative, so if our a value in front of x squared, if that is negative, then it, just like negative people like to frown, it flips it upside down. Negative people frown. Does that make sense? Easy way to remember it, yes.
Is it quadratic and parabola the same thing?
Yep. Quadratic, parabola, two different words for the same thing. Yeah. Any questions on that? So if our a value is positive, it's a smiley face, it's an upward facing parabola. If it's an upward facing parabola, it obviously has a minimum. If it's a downward facing parabola, it has a maximum. That's the highest point. That's the lowest point. Are we all good with that? We're just getting familiar with quadratics. Any questions? Okay, here's our first example. Let's apply that knowledge. So now you've pretty much learned everything you're going to learn about a parabola for today, and we're just going to apply that knowledge. So I'm going to look at this. It says, what are the coordinates of the vertex of each graph? Is it a minimum or maximum? So first of all, I like to say it's what is the coordinates of the vertex? I'm going to first ask myself, look at A. Is this a maximum or minimum? This is going to have a maximum value. So this is a max. And you can abbreviate and say max. So this is a maximum value. Well, right there is the highest point of our parabola, and that's our vertex. So what is the point of our vertex? It's an xy point. Over 0, up 3. 0, 3. That is our vertex. So our axis of symmetry, just besides the point, would be right there on that line. Questions? Okay, let's do another one. Is this a max or min? This has a minimum. Very good. It has a minimum value. Now, that is our vertex. So what is the xy point of our vertex? 1. Very good. 1, -1. We've answered the question. Are we all feeling comfortable with that? So if I wanted to draw in my axis of symmetry, it would be right here. At that vertex point. Okay, well, next one. What's the vertex of the graph? Is it a maximum or minimum? So once again, is this a max or min? It's a minimum. Very good. It has a lowest point. And then what is the vertex? It is not min. -2 down 3. -2, -3. And if I wanted to draw in my axis of symmetry, I could. Questions on that? We're all good so far. Yeah? All feeling okay? Okay. I want you and your groups really quick to do 1 and 2, come up with the answers for those, and then once you got that answer, let me know. So everybody see if you were right. Brendan, talk us through it.
Okay, so I think that they're both maximums. This one's a maximum, and the vertex on it is at the highest point. That's it. 2, 3.
Okay, I'm going to have you push pause. How many of you got that piece correct? Very good. You're absolutely correct.
Alright. And then on the second one, I thought that one was a maximum because the highest point on where x is 0 is 0a. So it would make a maximum that way.
On the right track. Can anyone elaborate on what you did? Yeah. Gary? Okay. Switch out Brendan for me. Very good, Brendan. Thank you. You did awesome.
Right.
On the right track. He's totally on that right track. Okay. Gary. Let's see what Gary has to say.
I kind of sketched it.
That's what I would love to see.
When I have
sketch it?
little, just oh my gosh, that's late. No, when they're not terribly big viewing windows. So 8 up would put you at 0A right there. 1 and 2 would be 1 and 2 right there, and then 2 and O would be right about there. 3 and 2 is back up, and then 4 and 8 is back up over here. So it's a minimum
Perfect.
Of 2 and 2.
Good. Perfect. Does everybody see how to do that? Does everybody see how to do that? Very good, Gary. Perfect. Absolutely correct. Okay, any questions? Gary, you're awesome. Thank you. All right, 1 through 3. Do those on the worksheet. I'm going to give you 1 minute or 1.5 minutes on the clock. That's all it should take you. We know. Okay, so now we're going to be graphing parabolas. So you can use the fact that a parabola is symmetric to graph it quickly. So there's a couple different ways we've learned to graph these. This is one way. First of all, once again, because a parabola is symmetric on that axis of symmetry, then you can graph it pretty quickly. So these are the steps to kind of graphing a parabola. First, find the vertex. So you're going to first find the coordinates of the vertex. And then you're going to find a couple points on the right side, or on one side of the parabola. So first of all, we find the vertex. Boom. All right, so then from there, you're going to find a couple points. I always find whole number points because they're easier to graph. So like, for example, here, and then this isn't a whole point, but my graph doesn't really have one. So I'm going to just go randomly right here. So if we find 2 points to the right, can't we say, okay, if we stamp that across that y-axis, wouldn't it map evenly? So we know it would be over here.
Yep.
And then it would map evenly from there, so it'd be right here.
Yep.
So do you see how easy it could be to graph? Does that make sense? So I'm requiring you to find the vertex and then 2 points to the right, and then once you know those, just map them across evenly. All right, now I'm telling you this. This is very important to know. For graphs of the function of the form y equals ax². So if we have a quadratic that has ax², it doesn't have bx, it doesn't have c, the vertex is at the origin, which means 0, 0. So once again, if it has the form y equals ax², then the vertex is always going to be at 0, 0. Is everybody good with that? Yes or no? Do you understand? Okay, so I always find that's the easiest way to find the vertex, if they have this form. All right, so here's my first example here. Graph the function y equals 1/3 x², make a table of values, then what's the domain and range? So first of all, let's graph the function. First of all, we're finding the vertex. Does this form have the form y equals ax²? Yeah, doesn't it? So what's my vertex? 0, 0. So I plot my vertex. Boom, 0, 0. That's my lowest or highest point. Now, just asking, is this going to be a smiley face or frowning face? Looking front. It's a positive, so it's going to be a smiley face. But I need you to be more exact. I need 2 exact points to the right. So now this is where I'm going to have you get out your graphing calculators here. So pull up your graphing calculator. We're going to type into our calculator 1/3 x², and we're going to graph it and look at the table of values. So you go to y equals. Everybody follow me. Go to y equals. So it was 1/3 x². So I do 1 divided by 3, and then x is right here. This is the x key, so variable x, and then squared. Is everybody there? Now hit graph, and you can look at the graph. So we know our graph's going to look like this, but once again, I'm going to make you be exact and give me at least 2 points. So even if you drew a rough sketch on a test and your points were not right, I'd mark it wrong. So we can get the general idea of what the quadratic looks like, but we want some actual values we can plot. So this is how you do that. Instead of the graph, we're going to do second. See how it says table right here, where the graph key is? So you do second graph, and that will take you to the XY table. Now guys, if we plug in these X values by hand, we're going to get these Y values. That's our input. We would get this out. So we could do this by hand, but why not use technology where we can? So I'm going to look for whole number points, guys. 0, 0, we've already plotted that. Look, there's a whole number point at 3, 3, so I'm going to use that. Then there's a whole number point at 6, I just need 2 points to the right of the vertex, and then you'll do 2 points to the left because it will map evenly. So 3, 3 and 6, 12. So I chose to use those points because they're whole numbers, so they're easy to graph. 3, 3, 6, 12. So I go over 3, up 1, 2, 3, over 6, up 12. That's going to be off the graph. Well, we know that this is our axis of symmetry for this parabola in particular, and it's going to stamp evenly across that y-axis. So 1, 2, 3. So 1, 2, 3. On this side, it's going to be over here evenly. And now I can draw my nice pretty U. Does that make sense, everybody? Okay, let's talk domain and range. Wait, do you have a question, Braylon?
Yeah.
Yeah.
Calculators.
Okay, I'll come help you in just a sec. Okay, actually, let's all talk calculators for a second. I need everybody, because you need to learn this. So everybody, how many of you had a little bit, and even if you didn't, you should pay attention. How many of you hit graph and you couldn't see your parabola? Okay, good. So this is a good point. Everybody should listen to this. Now maybe, this is usually what happened. So first of all, does everybody see how on my window here, I can see to -10 up to +10 on my X values. I can see down to -10 on my Y values and up to 10. Well, how I have that is I go into my window. So everybody see the window key. Everybody should go in. So in my window key, notice it says X min. Now window is just how much do you want to see of the graph. So you need to make sure your window's good. So see how it says x min? That means how far down do you want to see on the x-axis? A standard viewing window is -10 and 10. So x max means how far to the right do you want to see on the x-axis? So over here, I want to see at least up to 10. So mins have to be negative. Maxes need to be positive. So our x min is -10 and 10. Now x scale means how many tick marks do you want to look at? And I always have it at 1 because I want him to work in 1, 2, 3. I don't want to jump in 5, 10, 15s. Does that make sense, everybody? Now y min, that means how far down do you want to see on the y-axis? I wanted to see down as far as -10, so I have -10, and then y max, I wanted to see as far up as 10. Now once again, y scale is the tick marks. I want them to go in 1s, so I have it on 1. So a standard viewing window. Change your window. Now everybody hit graph again. That should fix some of it. If not, then you'll have to have me come check in a second. Okay, just a sec. Anybody? All right, so domain and range. So domain is x values. X values, left to right. It does not matter if this function's growing up. Where's my function growing on the x-axis to the left?
What? Say that again.
Okay, are we all ready to listen again? Domain and range. Domain is x values. Left and right only. It doesn't matter how far up or down. I'm talking left and right. Where's my function growing? Domain is x values. So where's it growing?
Left.
Left to where?
Forever.
Negative infinity, right? Isn't this negative infinity on my x-axis? Isn't it growing this way to negative infinity?
Yeah.
So our domain is negative infinity. Where's it growing to the right? I don't care that it's growing up. I mean right.
Positive.
Positive infinity. So it's growing from negative infinity to positive infinity. And our range is our y values. We always do the lowest y value to the highest y value. What's my lowest y value?
0.
Right? And then it's growing to where?
Positive.
Positive infinity. Did it touch down right at 0?
Yes.
So you need a bracket and then parentheses always go around infinities. Are we all okay with that? One more? Okay, we're going to do this one. Here we go. Y equals -3x². What's the domain and range? So the first thing we graph is the vertex. Does this have the form y equals ax²? Yep, so our vertex is at 0, 0. Then from there, plot 2 points to the right, reflect it. You tell me quickly so that I don't have to pull up my calculator again. What are some 2 whole points to the right? 1 negative what? 1 negative 3, okay? What's another whole number point?
2 negative 12.
2 and negative 12, all right, so down here. So then I know that this is my axis of symmetry, ding, 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 ding. So it's going to map evenly across there. So if that's there, and if that is over here, that'll be over here. So I'm able to graph this, and I missed that point. It's kind of hard because my shadow. Does everybody see how to do that? Okay, so then domain, once again, domain is left and right. It does not matter my function's growing down. Nothing to do with domain. Left to right. X values, where's my function growing to the left? Negative infinity, where's it growing to the right? Positive infinity, very good. And then our range is y values. You always put the smallest first. Where's it growing to? Negative infinity. And what's the largest y value? 0, and it includes 0. Questions on that? Okay, now I need you to do these problems. 4 through 6 on the worksheet. Ready, set, go. Okay, so next matter of business here. So once again, we know that we can look at the a value, which is in front of x². So once again, ax², the a value tells us a lot of things about a parabola. First of all, we've already learned that it tells us if it opens upward or downward. If it's positive, it's a smiley face, so it opens upward. If it's negative, it's a frowny face, it flips it upside down. And it's a downward facing parabola. Well, also that a value can tell you how stretched or compressed a parabola is. Now, the smaller the a value, the wider it gets. So once again, the smaller the a value, the wider it opens up. I'm going to say that again. The smaller the a value, the wider it opens up. But here is the catch. You have to look at the absolute value of a. Because that negative, if it's a negative, it just flips it upside down. So to decide if which one's smaller or larger, you can't account for the negative, because the negative just flips it. So that's why you always look at the absolute value of a to compare and see which one's widest to smallest. So here's my first example. Given these three parabolas, negative 4x squared, 1/4 x squared, and x squared, it wants us to say which one's the widest to the narrowest. So once again, let's look at this one. My a value is negative 4, but you have to look at the absolute value of negative 4, which is positive 4. So that's our a value we're going to be looking at to determine if it's wide or narrow, which one's widest and narrowest. We're going to take the absolute value of 1/4, which is 1/4. And we're going to take the absolute value of 1, which is 1. So in this, which of these is the smallest? 1/4. So this one's going to be the widest. This is the first widest. Which one's the next smallest? So this is our second widest parabola, and then this is the largest, right? So this is our third widest. Now also, look up here. These are the same functions that we just said were widest to narrowest, and this is what their functions look like. Wasn't this one the one we said was the narrowest, the least wide? Which, look at your pictures. Does that make sense? Yeah? We said this one was the widest. Does it look right? Is it the widest? Yes. And then this one is the next widest. So does everybody see how you can look at the pictures as well to determine? Yeah? Are we all okay with that? Okay, so do 7 through 10. Okay, next thing. We're doing good, guys, so come back to me here. Next thing. So first of all, so far we've only been dealing with quadratics that have the form y=ax². We haven't had the bx or the c. Now I'm going to talk about something that is of the form y=ax²+c. So the y-axis is the axis of symmetry for graphs of the function y=ax²+c, which is also true for y=ax². We knew that we had our origin at 0, 0, so our axis of symmetry would be on the y-axis. Now, everybody listen up. This is the cool part. The y=ax+c, the plus c part simply takes our parabola and shifts it up or down that amount. So it's the exact same parabola, it just shifts it up or down that amount. So our axis of symmetry will still be on the y-axis. So, once again, does everybody see how ax²+c? This just shifts our function up or down. Same function, just moves it up or down. We're all good? Okay, so it says, how is the graph of y=x²+3 different from the graph y=2x²? 2x²+3 is different than 2x². Well, let's look at it. 2x² originally was what we had, and then we have +3. So we now take that parabola and we just simply shift it up 3 units. Does everybody understand? So it was at the lowest or highest point, was at the origin. We've now shifted it up 3 values. So really what we're doing here is we're just going to shift all our y values up 3. So look, 8, if we shift it up 3, because this is the +3 part, that would become 11. If it was at 2 for x² and the +3 just shifts our y values up 3. Do you see how it's shifting up 3, all our y values? Is everybody good with that? X values are the same. The y values went up 3. So this was the graph of y=2x². We shifted it up 3. Same graph, just up 3 units. Everybody's good with that? Okay. Here's my next 2 examples here. So it says, graph each function. So first of all, we have y is equal to 1/2x² + 2. So let's go ahead and graph it used to be at the vertex, but now it's shifted up 2, right? Okay, now let's think about this. Is this going to be a smiley face or frowny face?
Smiley.
It's going to be a smiley face, right? Okay, but now I want you to take your calculators and graph 2 exact points to the right, and then we can fold it over the axis of symmetry. So you guys hurry and type that in your calculator and give me some points that I can graph. Because I want them to be as exact as possible for this. So 1 point is over 2 up 4. So over 2 up 4. Is there any other whole number points I can use?
4 and 10.
Over 4 up 10. Awesome. So we now have those 2 plotted. We know it stamps across evenly. So it maps across evenly over here. And 1, 2, 3, 4. So 1, 2, 3, 4. So So it maps evenly. So now I can draw in my parabola. Are we all comfortable with that? Do you all see how to do that? All right, now I'm going to hurry and do domain and range because that's what I'm going to have you do. We're only finishing up the front page. So for these problems, though, I'm going to have you do domain and range. So domain is x values. Where's it growing from left to right? Negative infinity to positive infinity. I'm going to call it this time all real numbers. That is negative infinity to positive infinity. Either answer works. Our range is our y values. What's our lowest point? Y values on the y-axis. 2. And it's growing to positive infinity. Included 2, and infinity always gets a parenthesis. Do we need to do this one?
What's on domain? What did you write? Domain?
Domain is all real numbers. That's the sign for all real numbers. You can use that. That's the same thing as negative infinity to positive infinity. Does that make sense? Do you want me to do this one? No? Where would my shift be? Up? Up 4. And then wouldn't it be flipped upside down? And you just find 2 points? Domain and range. So this is what's required of you. Whole front page. So up through 16 is 2. 11 through 16 you also need to tell me. So tell the domain and range. That's all that's going to be dealing with this worksheet. So you have the rest of the time to get help each other, and you are not allowed to put anything away